Today we are going to study the introduction to the HACCP system. We have already seen in the part 1 the HACCP system, its implementations and the prerequisite programs. So now let's understand the HACCP system, because what we have studied in the previous session was the initial introduction to the HACCP systems and the prerequisite programs, which is the foundation for the HACCP system. The HACCP implementation, it starts with the step 0. I will say step 0 because this is the most important step, because in any system when you start, you need to understand that the management of this organization which decides that HACCP needs to be implemented has to be committed to implement that. The step 1, which is the assemble the HACCP team. That means you need to involve the people and bring them together to make a team. Step 2 refers to the description of the product. The product includes finished products, raw materials and any product contact material which is coming in contact of the food products. The step 3 of the HACCP implementation is the identification of the intended use. When we say intended use, it means that who is going to consume my product when I am going to supply it. So there needs to be certain specific conditions of certain category of the product which need to be identified at this stage. Step 4, it's the construction of the flow diagram. That means right from the receipt of the raw material to the production finished product, we need to describe all our steps in a pictorial way and understand that how my product is moving from one place to another. Then step 5 says that you have made this flow diagram sitting in a room. Now it is the time to go out and verify that whatever we have made in the flow diagram is all correct. So all these steps from step 0 to step 5, these are the preparation for the HACCP implementation, because in none of these steps you have done a hazard analysis. So we refer it as a preparatory steps or the preliminary steps. In the Codex Alimentarius Commission, which defines the HACCP system, these 5 steps 1, 2, 3, 4, 5, that is from the assembling of the HACCP team, the on-site confirmation of the flow diagram, these steps are defined as the preliminary steps to hazard analysis. Now the step 6, that is the principal step 1, is the main step from where the hazard analysis starts. The hazard analysis is a very big term. To understand the hazard analysis, we need to first identify all the potential hazards. Now, how I will identify the potential hazards? One is that you need to identify these hazards from the raw material which you have listed in your step 2, that is your product description. And you need to identify your potential hazards which you have listed in your process flow, that is in step 4. So that is why these steps are called the preliminary steps. So you need to identify, you need to list out all these potential hazards. The second step is you do a hazard analysis. That means you identify the risk associated with these hazards. Now these are the 3 types of hazards: physical, chemical and biological for each process and for each raw material. Now you identify the probability and occurrence of these hazards, that is probability and severity. A combination of probability and severity will lead to a risk. So you identify these risks and then you try to develop the control measures to mitigate those potential hazards. Now the next step, that is the principal step 2, means now you have a list of your hazards, you need to determine the CCP. CCP is what? Critical control point. You have a list of mitigations, controls which you have identified from the principal step 1. Now out of these 10 control points, you need to identify which one is my most critical. So there is a way to identify it which we are going to learn in the next coming slides. The next step is the establishing the critical limit for each CCP. For example, out of 15, out of 10 control points, you have identified 2 points as critical points. That means you need to have a special controls here. if you know that this is my critical point and I need to have a special control, I need to establish a critical limit, a limit for that point. That means you accept and you reject based on those limits. So this is your principle step 3. Then we go to the principle step 4, which talks about monitoring of this system for critical control point. Because if you have established something, you need to see that the system is going as per your established limit. Then your principle step 5 says, whenever there is any failure, whenever a system goes up and down, you need to take a corrective action. So you establish a corrective action system. Your principle step 6 says you verify your system. All the time you are doing monitoring, corrective actions, but there is a need to re-verify and reconfirm and check whether everything is going on smoothly or not. This can be done by verification. Then the last principle step is to make documents and records of each of the above activity. So these are the principle. Your last step is to establish your documentations. Now, there is not this, after the principle step 7, there is no step defined as per the Codex Alimentarius Commission. However, there needs to be an additional step which we call as the operational phase, where you need to maintain and review your HACCP system time to time. That means you need to ensure that the system is moving on in the right direction. Now, how is your system, before you implement a particular system, what kind of a situation is there in the organization? There is a chaos, because if he is standing, he can do the monitoring. If another operator is there, he can keep the material in that way. So there is a chaos kind of a thing. There is no systems, no defined responsibility and authority, no defined accountability. Nobody knows what is hazards, what are the actually potential contaminations, what are my temperature requirements, my process controls. So once you implement a particular system, a management, there is a change from a chaos to a more structured system, so that everybody knows where they have to go. So everybody is aligned to one direction. Now the next stage to the improvement of this structure is to make simplification. That means now you know what all is to be done. Everybody is going on the same directions. Now you need to reduce your documentation, reduce the complexities of the procedures, because now your system is getting aligned in a structured way. So the next stage is simplification. And then the last stage is, now you have simplified your structured systems, you need to think of where I can improve my system and get the customer satisfaction. Now, in order to implement, we have already covered GMP, GHP prerequisites in our last sessions. We have already have a basic understanding now on the preparatory steps and the HACCP principles, which we have just seen in the previous slides. Then you have to go to the implementation and maintenance phase. So this particular slides tells you in brief that these are the few things which you need to implement in case you want to have an HACCP system in place. Now, as I said, step 0, the management commitment, is the first step in ensuring the safe food. Now, this management commitment will come from the top management policy. That means top management will make a system, a vision, a goal, a objective that meets the requirement of safe product, which needs to be a legal compliance, which needs to include the HACCP requirements, which needs to include the customer requirements for safe product. So this is the first step, which is step 0, which is where you may not see in any codex standard, but it is the first thing any organization decides to implement the food safety. Now we will understand in detail about each step, so that we can implement them in our industries. We can understand and we can go back and help the industries to implement it. Number 1 is the HACCP team. The size of the HACCP team depends upon the size of the organization. So it can be 4, it can be 6, it can be 2, it can be 3. There is no set defined limits. So the size of the limits, if there is a very big company, there are multiple process flows, probably we require a smaller group of people for each process flows to be developed, and then to a bigger HACCP team which can decide upon the overall food safety. The another important element of the HACCP team is that it has to be multidisciplinary. Multidisciplinary means it should have people from different departments, different area of work, so that we can have an inputs, we can develop the system in the best possible way, and we can identify any potential sources of contaminations and hazards in the industry. It may include people from engineering, maintenance, production, technology. They can be a quality manager, it can be a quality control officer, a microbiologist, a hygiene specialist, a logistic people who is maintaining the supply chain. It can be people from the legal department, it can be from any other department including the finance, purchasing, HR. So any people can be part of the HACCP team. So for HACCP team, you need to remember always this multidisciplinary structure is important. And another important thing is the competence of the team. That means team should understand and team should have the necessary competence to do the hazard analysis. This competence can come from the education, skills, training or experience. So these are the different things which you need to keep in mind about the HACCP team. The step 2 is the product description. That means you need to describe your product. The products includes your raw material and ingredients, it includes your product contact materials, and also the product description should clearly mention the product labeling needs. The third step is your identifying the intended use. Now here the intended use, when you are defining, it is very important to understand the potential abuses of the product. That means what can go wrong with my product. So you have to identify your potential users, who is going to consume my product, how my product is to be safely stored, how it is to be prepared, how it has to be served. So all these things to be well defined, and also unintended handling and use of the product taken into consideration. For example, if you take a Tetra pack of a juice and you open the seal and then do not refrigerate, the juice will get spoiled. Now the shelf life of the juice, the best before date says 6 months. Now you can claim and say, no, this 6 months has not gone and still it has spoiled. So that is why, to avoid this unintended handling, it is very clearly written in those bottles that 6 months is the best before date. Once open, consume within 3 days. Keep it refrigerated. These are different ways by which they are telling their consumers that you need to keep certain things in such conditions, refrigerated conditions, so that it doesn't get spoiled. And even in the refrigerated conditions, once open, it may not be able to take it after 3 days because there are chances of contamination. So this intended use will help you in developing your finished product specifications and informations for the customer. This is also a very important step because based on this user, you will do a hazard analysis in the principle step 1. Next step is the development of the process flow diagram. The process flow diagram should contain all the steps of the manufacturing process indicated where raw materials join the flow, where reworking and recycling takes place, where intermediates, byproducts and wastes are removed. Flow diagrams should sufficiently clear and detailed for potential hazards to be identified, and it should include relevant process data. On-site verification of the flow diagram, you need to confirm your flow diagram in such a way, because once you go out and actually see, then you will understand that my diagram is complete, it really identifies all the steps or not, whether it is providing all the operational periods or not. So that is to be confirmed in the on-site verification. And as I said earlier, these step 1 to step 5 are just the preliminary steps. So the principal step is yet to begin, and that is what is hazard analysis, which includes identification of the hazard. Now, to identify the hazards, you need to sometimes refer to the various sources of information. Now, where all from you will identify the potential sources, you will identify the reasons for the hazard identification. That will come from the literature, that will come from your flow diagram, that will come from the best practices in the industry. You can also get the hazards for a particular product, for a particular process steps from the internal and external experts in that area. Sometimes there are the regulatory guidelines available. That means regulatory requirements are there that pesticides residues should be maintained at this level. So now you understand that in the rice or in the wheat or in the other commodities where the regulatory body has defined a limit, that is a potential source of contamination. So right at the receiving stage, you will identify a pesticide residue of this is a potential hazard. So these are the different ways by which you can get the information of hazards, and you can utilize them in your HACCP plan. The customer complaints. Sometimes customer says that there is a problem of the packaging material and there is a problem of the color. So now you understand that there is a hazard, there can be potential hazard related to this particular commodity. There are epidemiological data is available, results of internal and external audit, and also sometimes the screening analysis are being carried out, which provides important sources of information. Once you have listed your hazards from the above sources, now it's a time to identify the risk. So the risk is the one where you will identify that what is the likelihood and what can be the, it's a bomb, risk is a bomb. So you need to identify the likelihood of having these kind of bombs in your system, and in case they explodes, what will be the consequences. So risk is a combination of probability and severity in terms of likelihood and consequences. Now, in order to do a risk assessment, the best way is to develop a scale. A scale can be anything 1 to 10, 1 to 5, 1 to 4, 1 to 3. So there are different ways of defining a scale. In this particular example, I am defining it from 1 to 5 as a likelihood scale and a consequences scale as 1 to 4, which starts from 1 means there is improbable, that means there is quite unlikely that this particular problem will occur or has ever occurred, and 5 means frequent, that means every day you find, for example, hair problem or some other problem. Then what will be the severity? It can be minor, it can be very high. So you need to understand that. Now based on this likelihood and severity, we can develop a matrix. That means if my likelihood is low and my consequences of failure is also low, then I categorize that particular hazard as a low risk. That means I may not like to establish a control measure for that hazard. If my likelihood is, let's say, 2 and my consequences is also 2, then I classify those particular commodities as a medium risk, or you can say 3, then I classify them as a medium risk. In such stage, we may control them with a smaller type of an operational control measure. When the likelihood of a failure is also high and the consequences of such failure is also high, we categorize it as a high risk commodities. That means every day there is a likelihood of a failure, or every monthly there is a likelihood of failure, and once this incident has occurred, it will actually spoil the brand image, it will lead to death. Then in that situation, we categorize them as a high risk commodities and we develop appropriate control measures. To conduct this hazard analysis, this is a sample hazard analysis sheet. So you describe your product, date and approval, other things. You define a particular step. Number 1 step, name of that step, type of hazard, that means first you identify physical, chemical and biological. When you say physical, you describe what physical, for example, glass due to windows or some other source. So you need to describe all these things in detail in this hazard analysis sheet. You decide the control measure, You assess the hazards based on the scale which you develop, likelihood and consequences. You give some numbers to them, then risk is coming, and then you will develop a level of control. That means if your risk is coming in the range of 2 to 20, then you have to decide that maybe anything above 10, anything above 15, we will categorize them as a high risk commodity. So this way you have to conduct the hazard analysis. Now the next step is determine the critical control point, because now I have conducted the hazard analysis. Now I know which is my high risk or significant risk material. Out of these significant risks, let's say 10 significant things has come into picture. I am now going to select from these 10 my most critical thing. Now this CCP is as per the Codex Alimentarius Commission given a decision tree, which is a 5-step procedure to identify, to decide on which is the most critical hazard. So whenever you are using this decision tree, we have to consider the steps in the flow diagrams which have a significant hazard and use the common sense. So now let's understand this. The definition of the CCP is a step at which control can be applied. Please understand this, that step, a control, there should be a possibility that a control can be applied and is important to prevent or eliminate a food safety hazard or reduce it to an acceptable level. That means either you prevent it, you eliminate it, or you reduce it to a level that it is no more a hazardous thing. While controlling the hazard, the basic idea is any significant hazards, eliminate the risk, reduce the risk, or accept the risk and take it under your control. So now let's see this decision tree which is being given by the Codex Alimentarius Commission, the CAC 1997. When we start the decision tree, we consider one particular step. We say, do the preventive control measure exist? The answer can be yes, or the answer can be no. In case there is no preventive control measure, that means the control cannot be applied. In that case, it is a simple thing that the control at this step is necessary. Yes, then you modify the step in the process so that you can have an appropriate preventive control measure. So this part is very clear that you need to have an effective preventive control measure in existence to make it a critical point. Now once you check the preventive control measure, the next step is this step a special step, a specifically designed step to eliminate or reduce the likely occurrence of a hazard to an acceptable level? Now for this you need to understand that there are certain steps which are part of the recipes and help in reduction of the hazards, and there are certain steps which are being specially added in a process flow to reduce a hazard to a particular level. Now to understand it, let me give you one example. The example of a dairy industry. So if we have to make a milk, if you have to make a poly pouch of the milk, what is the process we do? We take the milk, it is put in the plate freezers and it goes through the different sections, first pre-chilling, then it goes to a pasteurizer. That is, the pasteurization is being carried out at certain degree temperature, let's say 71 degree for 30 seconds, and then it is again immediately chilled. So now if I see this particular step of pasteurization, does it add any flavor to it? Does it add any specific things to it? No. But this is a special step which has been added so that it can reduce the hazards to an acceptable levels. So this is a special step and it can straight away come as a CCP instead of going through no. Now the next step, in case the answer is that it is not a special step, for example, let's say cooking. Now if we say cooking is not a special step, so we go to the next step, that could contamination with the hazard occur in excess of the acceptable level, or could these increase to an acceptable level? If the answer is yes, that means we need to find out the way that yes, if we do not cook a particular product, there will be an excessive amount of the hazard in it. For example, if we are making any meat dish, any chicken and anything, if we do not cook it, it may lead to a growth of the microorganisms. In that case, we say, will a subsequent step eliminate the identified hazard or reduce the likely occurrence to the acceptable levels? If the answer is yes, that means there is another step in the process flow diagram which can help in reduction of this hazard. We will not make it as a CCP. In case the answer is no, for example, if after cooking it actually goes into the plate of a consumer, then that means we need to consider this as a critical control point. So, this is an overview that in case you have to decide a step to a CCP or not to a CCP, you need to go to make it as a, go through all these steps and decide it as a CCP. So, this is about the critical control point, and we will go to the next step, critical limits, in the next session. So, this is all from our side. Thank you very much.